Hi everyone, for today's lesson we are going to learn how to solve systems of equations algebraically. Our learning targets for today is for you to be able to say, I can solve a system of equations algebraically. In our last lesson we learned how to graph different functions and identify their points of intersection. Those points of intersection were the solutions to the system. Well, graphing is not the best approach, and that's because it's really challenging to identify intersections that are fractions or decimals. Therefore, algebraically is actually a better approach. And one way that you can solve systems algebraically is with elimination. But elimination only works and is only best if you're talking about a system of linear equations. Also, elimination works best when you have one variable in your system that has a coefficient of 1. If all of your coefficients are not 1, well, elimination is not necessarily the best approach. So, what you want to do when it comes to elimination is you want to multiply. So your step, and what you want to do is you want to multiply the equations, and I'm going to put equations in parentheses, like the S in parentheses, equations by a number so that the coefficients of one variable are opposite signed values. For example, 2 and negative 2 are two numbers that are opposite signed. I'm going to retract what I just said about you want one of the coefficients to be 1. Really and truly, coefficients can be any number when it comes to elimination. It just means that you might need to multiply one or both of the equations by a different number in order to make it so that one of the coefficients are opposite signed. This problem is actually kind of easy because it's relatively obvious which variable to eliminate, and in this problem you have a choice, of course, but in this problem I would probably eliminate the x's because we can very easily multiply the first equation by negative 3, and therefore we would end up with negative 3x minus 12y is equal to negative 3. You could have multiplied this bottom equation by negative 2 and eliminated the y's, and that would have been fine as well. You want to pick whichever variable or whichever set of coefficients are the easiest to work with. I personally think that the x's are easiest to work with. So now what you do is, since you've multiplied both sides by negative 3, distributed that negative 3 to each term, you bring it and line up all of your x's, your y's, and your coefficients, and you're going to add those numbers going straight down. This is called elimination, and what's going to happen is one variable will be eliminated, and in this case that is x. And we are left with negative 10y is equal to negative 15. I'm going to divide both sides by negative 10, and we find that y is equal to, simplifying negative 15 over negative 10, we find that y is equal to 3/2. So in our ordered pair, our point of intersection, so far I have 3/2 is the y part of that intersection. So now what I'm going to do is I'm going to substitute 3/2 back into one of my equations, and it really doesn't matter which equation you choose. So I am going to choose x plus 4 times 3/2 is equal to 1. I'm just going to choose one of the equations, and it doesn't matter. You could have chosen the second equation, but always use an original equation. And now I'm going to solve for x. So I have x plus This is 12 divided by 2, which is 6, is equal to 1. I'm going to subtract 6 on both sides, and I find that x is equal to negative 5. So my point of intersection and my solution is negative 5 3/2. And it's always beneficial to substitute that ordered pair back into the original problem just to verify that you got that answer correct. So I'm going to plug negative 5 plus 4 times 3/2, and I'm going to see, is that equal to 1? Is negative 5 plus, this is 12 divided by 2, which is 6, equal to 1? It is. Is 3 times negative 5 plus 2 times 3/2 equal to negative 12? So this is negative 15 plus, this is 6 divided by 2, which is 3. Is that equal to negative 12? It is. So therefore, we can conclude that negative 5 3/2 is indeed a solution. This is called the process of elimination. And once again, this only works if you're working with a linear and a linear, a system of linear equations. So now what we're going to do is we are going to solve linear and quadratic systems using substitution. So what substitution means is that you want to get one variable alone. And substitute the expression that it equals into the other equation. So in substitution, you want to get one variable alone and then substitute that expression into the other equation. Fortunately for us, we already have one variable alone, and we learned yesterday that whenever we're working with linears and quadratic systems, that you could end up with one solution, two solutions, or no solution. So we are going to see different things happen that could produce one, two, or no solution. So nice thing about number 2 is that y equals 6. Y, we already have it alone. We simply are going to replace or substitute 6 into our first equation. So I'm going to write x squared plus 6 minus 3 squared, and I'm going to solve for x by setting it equal to 25. So I have x squared plus 6 minus 3 is 3. 3 squared is 9. This is equal to 25. My job is to get x alone and solve for x. So I'm going to subtract 9 on both sides, and I end up with x squared is equal to 16. I'm going to take the square root of x squared and the square root of 16 to get x equals. Now, because I'm using square roots on both sides, I'm going to have plus or minus in my answer. So the x equals plus or minus 4. So this equation up here is really y equals 0x plus 6. So I'm going to substitute two different values, 4 and negative 4, into this equation. So I'm going to write y is equal to 0 times 4 plus 6, and we end up with y is equal to 6 still. And y is equal to 0 times negative 4 plus 6, and once again we end up with y equals 6. So our two ordered pairs are going to be 4, 6 and negative 4, 6. And it's always helpful and really important to check your solutions by substituting both ordered pairs into the original problem. Obviously, we know that it works, 4, 6 and negative 4, 6 work with our second equation. What we want to see is, does it work with the first equation? So I am going to write, for my check stop, 4 squared plus 6 minus 3 squared, does that equal 25? Is 16 plus 3 squared, which is 9, equal to 25? Yes, it is. And is negative 4 in parentheses squared plus 6 minus 3 squared equal to 25? Once again, 16 plus 9 does indeed equal 25. So yes, there does exist two solutions for this system. Let's look at number 3. Number 3 is really nice. We already know that what y is equal to. Y is equal to 2x. So I'm going to substitute 2x into that top equation, into that first equation. So I'm going to put in parentheses 2x and I'm going to square it. And I strongly recommend that whenever you substitute, you always use parentheses. And we're going to set it equal to 8x. 2x squared, that means 2x times 2x. And we're going to set it equal to 8x. This is 4x squared equals 8x. This is a quadratic equation. And what you want to do for quadratic equations when you have two sets of terms that both have x's in it is you want to set it equal to 0 and factor. So I'm going to write 4x squared minus 8x is equal to 0. 4x squared and 8x both have in common a 4x, with our leftovers being x minus 2. Now, any part containing a variable is going to be set equal to 0. So the 4x and the x minus 2, both of those pieces will be set equal to 0. So I'm going to solve for x, and I find that x is equal to 0 or x is equal to 2. You do not need to show this work right here, but we do have two values of x. And now we're going to substitute those two values back into one of the equations, preferably the one where you're solving for y, since we know what x is. So I have y is equal to 2 times, and I'm going to put in 0, and I find that y is equal to 0. So this produces the ordered pair 0, 0. Then I'm going to write y is equal to 2 times, and I'm going to plug 2 in. 2 times 2 is 4. So that produces the ordered pair 2, 4. And now we are going to check our answers. So we already know that, yes, 2 times 2 equals 4 and 2 times 0 is equal to 0. So we don't need to check with this equation, but we do need to check with the first one. And so this is going to be y squared. So that's going to be 0 squared. Is that equal to 8 times 0? Well, yeah, 0 equals 0, so that definitely works. So now I'm going to put 4. Is that equal to 2 times 2? Yes, indeed, that does work. So we've checked, we've verified, and there are two solutions. For example, number 4. We already have y alone. That expression is negative 3x plus 10, and I'm going to substitute that entire expression into y. And so this is going to be x squared plus parentheses negative 3x plus 10. That whole expression squared is equal to 10. Whatever you do, do not distribute the exponent. You have to set up 2 parentheses and you will need to FOIL. Please be careful. That is a common error that students make. So this is going to be x squared plus negative 3x plus 10 times itself twice. This is going to equal 10. So now I'm going to FOIL. And I have x squared plus 9x squared minus 30x minus 30x plus 100 is equal to 10. This is a quadratic equation, so what I need to do is I need to condense my condense my like terms and make it equal to 0 because I will likely need to factor. So combining my like terms, I have 10x squared minus 60x, and I'm going to subtract 10 on both sides so that I end up with plus 90 is equal to 0. 10, 60, and 90 are all divisible by 10, so I'm going to factor out a 10 to make this problem easier, and I end up with x squared minus 6x plus 9 is equal to 0. X squared minus 6x plus 9, this is a perfect square trinomial. So that's a really easy thing to factor. So that's going to be 10 times x minus 3 squared is equal to 0. So any part containing a variable you can set equal to 0 because this is technically 10 times x minus 3 times x minus 3 equals 0. So you would set x minus 3 equal to 0, add 3 to both sides, and we find that x equals 3, indicating that we would only have one solution, one location in which these two functions or two graphs would intersect with each other. X squared plus y squared equals 10 is a circle, and this is a line. So I'm going to substitute x equals 3 back into my easy function of y equals negative 3x plus 10 so that I can find what y equals. So I'm going to write y equals negative 3 times 3 plus 10. So this is y equals negative 9 plus 10, which is positive 1. So my ordered pair is 3, 1. And I'm going to verify that 3, 1 is indeed our solution. So I already know that it works with this equation since I used that equation to find the 1. So I don't need to show that. Instead, I'm just going to use my top equation, which is going to be 3 squared plus 1 squared. Does that equal 10? Is 9 plus 1 equal to 10? It is. So therefore, we can say that 3, 1 is indeed our answer. In problem number 5, we have a different type of problem in which we have a y squared. This indicates that we would have a parabola pointing to the left or right. I just want you to go with it for this type of problem, and you will see what happens with it. So first of all, we don't have y alone. We don't have x alone. So when you don't have one of those variables alone, do some manipulation of the easier equation and get a variable alone. So I would recommend in this top equation to get y alone. To get y alone, we would add 3x to both sides. And our new equation is y equals 3x plus 6. So now I'm going to substitute this expression of 3x plus 6 into the second equation. So now I have 8x plus parentheses 3x plus 6. That whole expression is going to be squared. Plus 24 is equal to 0. Once again, do not distribute the square, and instead we're going to write 8x plus 3x plus 6 times itself twice. And then we're going to add 24 at the end. This is going to turn into a quadratic equation, which means that I will have to factor or use quadratic formula by the end. And so we do want it to remain equaling 0. So I'm going to write 8x plus, and I'm going to do the FOIL. And we have 9x squared plus 18x plus 18x plus 36 plus 24 equals 0. Combining my like terms and putting it in standard form, we have 9x squared, 8x plus 18 plus 18, that is equal to 44, so plus 44x, plus 36 plus 24, that is equal to 60, is equal to 0. 9, 44, and 60 are not related to each other. And on top of that, if you were to really analyze this problem, you would find that it is not factorable. Therefore, when something is not factorable, no worries, you're going to use the quadratic formula. So I'm going to write x equals the opposite of b, which is negative 44, plus or minus the square root of b squared, which is 44 squared, minus 4 times 9 times 60. This is all over 2 times 9. So I'm going to write x equals negative 44 plus or minus the square root of something divided by 18. And when I put 44 squared minus 4 times 9 times 60 into my calculator, I end up with negative 224, which this is imaginary. And we are working with real solutions. So because this is imaginary, that means no real solution. And no real solution means that there's no points of intersection. Please flip to the next page. I would like you to please pause the video at this time, and I would like you to complete the entire next page, which is all your turns on your own at this time. Then I want you to restart the video and check to see your answers. All right, here we go. So what we have here is the intersection between a circle and a vertical line of x equals 1. What's nice about this problem is we already know what x is equal to, so I'm simply going to substitute 1 in for x. So that's going to be 1 minus 3 squared plus y minus 4 squared is equal to 4. So I have 1 minus 3 squared, which is negative 2. Negative 2 squared is 4. 4 plus y minus 4 squared is equal to 4. I can get this y minus 4 squared alone, so I can use square roots in order to solve. So I'm going to subtract 4 on both sides, and I end up with y minus 4 squared is equal to 0. I'm going to take the square root of both sides, and I end up with y minus 4 is equal to 0. You don't want to write plus or minus 0 because that's awkward. Adding 4 to both sides, we end up with y is equal to 4. So in this problem, there's only one solution, and that is located at 1, 4. And you can verify your answer by saying, is 1 minus 3 squared plus 4 minus 4 squared equal to 4? Negative 2 squared is 4 plus 0 is indeed equal to 4. So it does end up working out. Number 2. We want to get one of the variables alone, and it doesn't matter which one you choose. I'm going to get y alone, so I end up with y is equal to negative x, and I'm going to substitute negative x in for y. Please be careful with your signs here. So I'm going to write x squared minus parentheses negative x minus 6 is equal to 0. A negative negative makes a positive, so this is really x squared plus x minus 6 is equal to 0. I'm going to factor by splitting apart the x squared into an x and an x, and ask myself what two numbers multiply together to equal negative 6, but together add to equal positive 1, and that's a positive 3 and a negative 2. So my two solutions are x equals negative 3 or x equals positive 2. And I'm going to substitute both of these values back into the other equation, which is going to be y equals negative x. So I'm going to write y is equal to negative 1 times negative 3. So y equals 3. So my ordered pair here would be negative 3, 3. And for this x value, I'm going to write y equals negative 1 times 2. And I'm putting a negative 1 here just because it's a negative in front of the x. So that's going to be y equals negative 2. Therefore, that ordered pair is 2, negative 2. And I'm going to substitute these ordered pairs back into the other equation because I can already tell that 3 plus negative 3 equals 0 and 2 plus negative 2 equals 0. So I already know it works with the second equation because I used it. So now I'm going to work with the first equation or the other equation. And I'm going to say negative 3 squared minus 3 minus 6, does that equal 0? Is 9 minus 3 minus 6 equal to 0? Yes, it is. And then I'm going to put positive 2 squared minus negative 2 minus 6, does that equal 0? Is 4, hold on, I do that correctly. Plus 4 minus 6 equal to 0? It's looking like that did not work out. I'm sorry, not plus 4. It's plus 2. Thank you. Ugh. 4 plus 2 is 6. 6 minus 6 does indeed equal 0. Please forgive me on that, guys. All right. So, yes, they both indeed work out. Let's look at your turn number 3. So with your turn number 3, we are going to get one of our variables alone. So I'm going to bring x to the other side and make this y equals negative x plus 6. You could always subtract y on both sides and find x first. It does not matter. And I'm going to substitute this expression in for my y squared. This is a line with a circle. So I'm going to write 3x squared plus parentheses negative x plus 6. That whole expression squared is equal to 12. For this problem, we do not want to bring the 3x squared to the other side. It is different than this problem up here. This problem up here, we were able to get a parentheses squared alone, but in this problem, because of the x squared, that's not what we do. And instead, you will have to write out 2 parentheses. So we have 3x squared plus negative x plus 6 times negative x plus 6. This is going to equal 12. This is going to be a quadratic equation, which means that we're going to want it to equal 0. So eventually I'll bring that 12 to the other side. So I'm going to write 3x squared plus x squared minus 6x plus 36 is equal to 12. I'm going to combine my like terms to make this 4x squared minus 12x, and I'm going to subtract 12 on both sides so that I end up with plus 24 is equal to 0. 4, negative 12, and 24 are all divisible by 4, so I'm going to factor out the 4. And I end up with x squared minus 3x plus 6. Does that equal 0? Well, when looking at this quadratic, I have to figure out what 2 numbers multiply together to equal 6, but together add to equal negative 3. And the factors of 6 are 2 and 3. We want it to equal negative 3, nothing, and then we have 1 and 6. This is not factorable. So therefore, we're going to use the quadratic equation in order to factor the x squared minus 3x plus 6. So I'm going to write x equals the opposite of b, which is 3, plus or minus the square root of b squared, which is going to be 9 minus 4 times 1 times 6. This is all over 2 times 1. So I'm going to write x equals 3 plus or minus the square root of something divided by 2. And when I put 9 minus 4 times 1 times 6 into my calculator, I end up with negative 15, which is imaginary. And because it is imaginary, that means that we have no solution. And that is the end of this lesson. If you have any questions over anything, please feel free to email me. Otherwise, I hope you have a wonderful day.